5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome, and thanks for joining me today to introduce you to the James Webb Telescope. And in just 1 year from today, the world's largest telescope ever built will rocket into deep space to look back in time and find planets that could sustain life in our galaxy. This telescope is 7 times larger than Hubble. More next on About Space today. Are you ready to fly away on a dream vacation? For cruises and all-inclusive resort vacations, call D&D Cruise and Tours at 877-747-8631. That's 877-747-8631. And see us on Facebook, D&D Cruise and Tours, where your dreams become a reality. Welcome back. During a news conference at the Goddard Space Flight Center in Greenbelt, Maryland, John Mather, the senior scientist and astrophysicist who helped create the telescope, is introduced.
So John has been at Goddard for a long time. He is our only and first Nobel Prize winner. He's been with the James Webb Space Telescope almost since its inception, and certainly has all of the information about what the James Webb can do and will do when it ultimately gets into orbit. John?
We've done 2 decades of innovation and hard work, and this is the result. We are opening up a whole new territory of astronomy. So we will see things that we've never been able to see before because this telescope is much more powerful than even the great Hubble telescope. So what makes it more powerful? Number one, it's gigantic. You can see this beautiful gold telescope is 7 times the collecting area of the Hubble telescope. So that's the beginning. The second thing is it's designed to collect infrared light. So infrared is something that you cannot really see with your eyes. The Hubble telescope can see a little bit of it, but it's not cold. So the Hubble telescope glows and emits infrared light itself, so you cannot use it to do all of the things that astronomers have identified as their next top priority. So this telescope is going to be in outer space. It's going to be cooled to a very low temperature of 45 degrees above absolute zero, really chilly, so that it does not glow. So it's going to be very perfect as well. This mirror that you see, if you made it, stretched it out to be the size of the entire United States, the hills and valleys on that mirror would be a few inches high. It's an astonishing engineering accomplishment. It is too big to go into the rocket, so it'll be folded up. And there's another astonishing engineering accomplishment there. So let's see, also to give you some perspective about what we can do with it, if you were a bumblebee hovering out at the distance of the moon, we would be able to see you, both by your reflected sunlight and by the thermal radiation, the heat that you emit. So how can we do that? We have brilliant engineering. We also have the most astonishingly good detectors that have ever been made for picking up this infrared light. So I don't want to exaggerate, but that's beyond a miracle as far as my perspective is concerned. The way that the telescope works, light comes from the sky, bounces off that big mirror. It's concave, and it will be focused down towards a little point. So that's like the sensors in your cell phone camera, only way, way, way better. And they pick up wavelengths that we cannot see with your cell phone camera or with your eye. So the wavelengths we pick up begin at 0.6 microns wavelength, which is sort of reddish, and you'd be able to see it, but they go out to 28 microns, which is much, much longer, and you couldn't see it, but if it were really bright, you could feel the heat of it. So this is why we're opening up a new territory of science. You cannot do this experiment on the ground because the atmosphere glows and is opaque. The telescope on the ground would glow as well. So you just can't do it anyway else besides going into space. So you see this very complex thing and you say, wasn't that pretty complicated? The answer is we have to have it to do the science that we're after. Let me say a little bit about the science that we are after. We would like to know, basically, how did we get here from the Big Bang? So what happened after the Big Bang? The first stars and galaxies happened some way. We have lots of predictions. We have supercomputer simulations. We can even show you a movie how it might have happened, but we don't know. You have to go look. Nature has this way of defeating our imagination. And so astronomy has always been an observational science, and you just cannot depend on your imagination alone. So what happened after that? Well, the galaxies grew. The Milky Way, which we live in as 100 billion stars, probably was formed by thousands of little bits being pulled together by gravity over billions of years. So the Milky Way that we live in today is very different from what it was when it was young. Did not all form at once. Probably. Got to find out. How do the planets and the stars get formed? Well, right now we're just beginning to see planets growing around other stars. So the Webb Telescope will be pointed at places where stars and planets are being born today. There's several of them being born every year in the Milky Way. So some of them are good targets for us, and we hope to see the details. Closer to home, we hope to see what about those little planets out there. The solar system, we've got lots of planets, some dwarf planets, and we will look at everything from Mars outwards. Everything is in view for our telescope. Around other stars, we'll be looking for planets around them. So sometimes they go in front of the star and they make the star blink, and you can say, I know something happened. This telescope is big enough to analyze the light that went through the planetary atmosphere and say, what are the chemicals in the atmosphere of another planet? Isn't that spectacular? So we will be able to tell you a little bit about whether those little planets out there are like Earth.
Dr. John Mather and the James Webb Telescope. Thank you for joining me today, and be sure to follow us on Facebook at aboutspace.today. And listen to our Friday news report, America in Space, with Rick Potluck from our Washington Bureau. And don't forget, share our program with your family and friends. I'm David Denault, and this has been About Space Today.